it will become 0.9 kilonewton per meter. So 0.9 multiplied by 4, you will get here 3.6. Do you understand? Okay. So now what is the question? We have to find out the internal forces here at point C. But do you know that how did you get this 1 meter, this 7.2? All these 7.2 are the reaction of the small beams, and this 3.6 is the reaction of exterior beams. 7.2 for the interior and 3.6 for the exterior. Okay. Is it difficult to find out the
total weight on the beam?
So, is it difficult to find out the shear force and moment at this point?
No.
Okay, let's do it. First of all, we have to find out the total reaction. So, you can count it because the beam is symmetric. The beam is symmetric and the load is symmetric. So, you just find out the total load and divide by 2. So 7.2 multiplied by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 7.2 multiplied by 12 divided by 2. What is the answer?
What's the
7.2 multiplied by 12 divided by 2.
should be 43.2.
Okay, so it should be 43.2 and it is 43.2. Okay. This is the small joist. I mean, I already told you that how the load is 7.2, how this reaction is 7.2. This is the same thing which we have discussed here. Okay. So let's cut this section. Let's cut this section and draw it here. Now you have two choices. Either you can consider the right side or you can consider the left side.
Left is easy.
Left is easier, so I will recommend you to choose the left side. But if you are aggressive, you can use the right one. It's up to you. Okay. So you have one force here, 1 kilonewton. 1, 2, and the third one. 3, and you have a reaction here upwards. And this is 1 meter.
Yeah.
1 meter. And this is point C. This distance is also 1 meter.
No, 1.2. 1.2 meters.
This is 1 meter. And this distance is 1.2 meter. If I'm not wrong. Yes. We are not sure about this distance, I'm sorry. We are not sure about this distance. It's not given. Okay, how much is this load? 7.2. 7.2 and 7.2.
No,
3.6.
The exterior.
Yes. Okay. Now apply the equilibrium. Let's apply sigma Fy at this point. So in order to bring this beam in equilibrium, there will be one force here.
Shear force.
Now, should it upward or downward? Which way?
Downwards.
You can assume upward, but if your answer is negative, it means your assumption was wrong. Do you understand? If you say you want to assume upward, you can do that, but if your answer is negative, it means you assume the wrong way. Okay, you assume this way, so it should be positive. Now our answer should be positive. So let's apply sigma Fy is equal to 0. For equilibrium, the sigma Fy should be equal to 0. So minus 3.6 minus 7.2
minus 7.2
minus V
plus 43.2
should be equal to
0.
so this will be
Uh, 25.2.
positive or negative?
No, it's positive.
Positive.
It would be positive.
Plus how much?
25.2.
Newton, kilonewton.
The shear force
Yes,
the shear
Okay.
force up.
So this is the shear force. Now the moment. So you can assume now the moment here.
And C.
You can assume in any
Any
direction.
direction.
But I will recommend you to assume
Yeah, clockwise.
Clockwise.
And now you can consider any sign convention. Like counterclockwise positive, the same what we are using. Counterclockwise positive. So take moment at this point C.
Alright. 7.2 into 1.
3.6
And 2.4.
into 1, yeah,
2.4.
into 2.4. Seven point two. It is clockwise or counterclockwise at this point?
Counterclockwise.
Positive.
No, اللي تحت. Plus.
Plus 7.2 into 2.4 or 2.2?
1.2. Should be.
Is this 2.4 or
1.2.
I think 2.5 or 3.6. Because it's.
how much will be this distance? Please tell me. It should be 2.4. Yes, you're right. This is 1.2 and 1.2. So now 7.2 into how much will be this distance?
1.4.
Yes, it will be 1.4. Plus.
How we get how we get the distance? The distance.
See, this distance is given 1.2, 1.2.
Yeah, for the 3.6.
So this distance is 1. So this distance will be 2.4 minus 1. 1.4
Oh, okay.
plus
4 3.2.
0.4.
0.14, yes.
And what about this force?
Minus.
Minus 43 by 2 multiplied
3.2 into 1.2.
Into
1.2.
and this m counterclockwise. This force you produce clockwise, so it is negative. And it will be
Plus MC.
plus m is equal to 0. This is sigma m is equal to 0. So you can get m. How much is m? Just solve this equation. How much? 30 or 13?
30.
Done. Okay, this is the next example. Yes?
From the beginning. How it comes 7.2 in each point?
You know, this beam, this one, this beam, it is 8 meter long, okay, and the load on this beam is 1.8 kilonewton per square meter multiplied by a spacing, and that spacing is 1. So the load on this beam this beam, okay, the load on this beam is UDL.
Yeah.
So, and the load is 1.8 kilonewton per meter. Okay, and how much is this length? 8 meter. So you tell me how much will be the reaction. Tell me.
Into
1.8 multiplied by 8 divided by 2, and that is 7.2. So this 7.2 load is going down on this from this side and down on the other side. So on this beam now you have 7.2 at each joist location.
43 point. How about the exterior?
But the exterior one, if you see, the exterior one is supporting half of the distance. For example, this joist is supporting this distance, but this exterior is supporting only
Half meter.
0.5.
Yeah.
That's why we have 3.6 for the exterior and 7.2 for the interior. Let's go next. Okay, now what is the question? Anyone can read from the book? What do we need?
The 9K force and figure 4A is supported by the floor panel DE, which in turn is simply supported at its ends by floor beams. These beams transmit their loads to the simply supported girder AB. Determine the internal shear and moment acting at point C in the girder.
So what do we need?
Internal shear and moment acting at point C.
Let me read this question again for you. It is example 4.3 and it is saying the 45 kilonewton force in this figure is supported by the floor panel DE. So DE, at point DE there is a load 45 kilonewton on this panel DE, which in turn is simply supported at its ends. It means that this panel DE is simply supported at point D and E. It means the reaction will be calculated based upon the simply supported conditions. And these being transmit their loads to the simply supported girder AB. And now the load is going to the girder AB. Determine the internal shear and the moment at point C. So we need the shear force and the bending moment at point C. Any one of you who wanted to do this problem here is welcome. Okay? So yeah, you can come here and let's solve it. And let's see, I give you some time, like,
Do we have to be vocal about it or just do the thing and
I mean, you want to take help, you can take.
No, I'm saying like, do I have to talk to the and explain to the students?
No need, just do it here. So this is panel DE. Sigma MD. Okay.
It's simply supported, right?
Yes, simple sport. Is he? Is it he is doing right or wrong? Okay. EY will be 15. It will be 15 kilometer. EY will be 15 and
13.
dy will be 30. It's 30. Great. Now the shear and the moment at point C. Now what should you do next? Section?
No, I have to transfer the load.
It will be
Compare the load.
حول له الدهان.
Isn't that the middle? Point C, is it the middle? The right?
No.
Seven.
0.5. 0.25.
And 0.5 to the
So
right.
what you should do next? First draw this girder and show the forces.
ارسم الاي بي الحين هذا.
I help you. Just draw this girder. This is a girder AB. You can consider this simply supported. There is no horizontal force, so horizontal reaction will be zero. Yes. Okay. So now you have this is 30 and this one is 15.
عندك مسافات.
Okay, and you need, here is your point C, 3.75 meters, and this distance is
3.4.
3 meters.
Yeah, 3 meter.
The total is 6 meters. Now you need these two reactions. First find the reactions.
عندك مسافة بعد.
Please understand with him. Don't waste your time. See, and if he do any mistake, he does any mistake, just stop him. Help him.
Lost the Wi-Fi system.
Small z. So B bar is how much? Calculate.
شنو بنت 25 قلنا بس عبد الغني كنا راح نوزع 26.25
AY
sigma 5
Yes.
Okay, so now you have A bar and B bar. So how much will be the shear force? Silent please. How much will be the shear force at point C, this point?
هنقطع عندك
You can solve it here.
قال لك هذا خلاص.
Okay.
ارسم قبل لاين سكتش قبل.
Right or left? Right.
26 ربع. بس عندي 15.
This distance.
2.5. هذا مسافة كلها هذا.
6 minus
1.5 اللي فوق. 1.5 تصير. 1.5 متر تصير من بين 15 إلى السبورت. 1.5 إيه. هذا من الرسم بين الاي والبي هذا رسم الكليته عادة
15 I got 1.5 اليمين. Another moment.
عادل المسافات. بس طبعا السين والبي والصوت من الاي للبي. انت تحسب كم خطوة تحت 15 ناقص 26
المفروض تحت.
يعني هو حط ازيوم تحت.
You know,
0.5
if
meters.
shear is clockwise, it should be positive, and if shear is counterclockwise, it should be negative. If you
Shear.
move next, I will tell at the end.
لا هذا هو assumption عدل. ايه هو سوى assumption تحت. لو طبعا ما في طبعا دي ايه بنا عكس الصدر بس هذا الفاصل هذا
ليه 0.5
هنا في كلمة رجال نقول لك ما تسمع.
Now, see here, you assume this way, it is producing the shear is counterclockwise.
Yeah.
Do you understand?
Yeah.
So I told you the clockwise rotation is positive. So it is counterclockwise, so this V should be negative. Do you understand? If you understand, it's good. If you do not understand, go back, read your book, and then understand.
When we say negative, we don't switch the direction. That's it. It's negative downwards.
When you cut a section from right, this is the positive shear. If you cut a section, yeah, up. Because this shear is producing clockwise, so this should be positive. Do you understand?
Yes.
You should assume this direction. Okay. So if you assume this direction, you will get negative answer. If you don't want to see the answer, just see it is clockwise.
حطها ماينس 11 الحين.
So the
حطها ماينس 11.
خلاص الحين عدل.
Yes, just put negative.
لازم تحط ماينس. ايه غير
Silent, please. Silent. See here. This is a positive shear. See. Because why this is positive? It is producing clockwise rotation. It is positive because it is producing clockwise. I told you this before. Okay, well.
Doctor, if you don't consider this and our assumption.
Now, for example, as you did what you did. To go back. Like what you did, you assumed this direction and your answer was positive. Your answer was positive.
Yes.
So our direction is okay.
But you should know that as a universal rule, the clockwise shear is positive and this shear is producing counterclockwise. So this shear by default will be negative. If you do not want to consider the sign convention, just keep this thing in your mind because it is producing clockwise, so counterclockwise. See this shear, it is negative.
So, teacher, maybe we add a note like.
You should tell here it is negative shear.
Okay.
Either you should do it by your common sense or you should assume these directions, what are here during the question. You should assume the positive shear, this one. If you get the negative answer, it means the shear is negative. Okay? Well, it was a good attempt.
There is a false negative.
Negative force, you mean?
Yes.
Shear is positive and negative as well.
But if we have a negative sharp, negative force, that means we have to change the force direction.
Either you change the direction or you remember it, that it is negative. Well, because if you remember, when you draw the shear force, like if a beam and the load is acting, like for this beam, the shear force will be half. It will be something this, and then it will become 0. Do you understand? This is a 0 point. And this shear value is, AY is how much? 18.7. 18.7 minus 30, it will be how much? 11.3. And then it will become,
Minus 50.
and then it will become, so at point C, the shear is
minus